So students, today we will start our ninth experiment, and the aim of the experiment is measurement of power of a three-phase load using 2 wattmeter method and verification of the result using one three-phase wattmeter. So from the aim of the experiment, it is very clear that we have to verify that the reading of this single phase wattmeter of two single phase wattmeters will give you exactly the same readings as it will yield you for a single three phase wattmeters. So by using two wattmeters you can also measure the three phase power. So how? Let us now discuss it. So for performing this experiment we require the following apparatus. These are the ammeters, which is basically a dynamometer type having three phase and 50 hertz it's as its specification. We require one such kind of wattmeter. The second apparatus required is a three phase induction motor trainer kit. Here it is optional. We have chosen a three phase induction trainer kit. You can also take any other three phase induction motor or a three phase load bank also. So it depends upon you how you choose your load. So here we have taken as a three phase induction motor trainer kit. Now the specification range of this induction motor trainer kit is 3 phase 50 hertz, zero point 0.5 HP and drawing a current of 2 ampere. Similarly, the quantity required here is 1. The other equipments required are a wattmeter, which is of dynamometer type having 50 hertz and single phase. The quantity required is 2. And why it has been required 2? Because we have to verify the power drawn by two single phase wattmeter will be equal to a single three phase wattmeter. So now this two wattmeters is already connected in the kit, so we will just connect them. There is no additional wattmeters which will take. So we will start with the theory. Right. So now the theory. Three phase wattmeters are usually a dynamometer type which consists of two separate wattmeters, movement together in one case with two moving coils mounted on a single spindle. There are two current coils and two pressure coils. A current coil along with a pressure coil constitutes an element. The three phase wattmeter consists of two such elements. Wattmeter measures active power consumed by three phase load. Unit of power is watts or horsepower. Now P is equal to root 3 V into I cos phi watts, where V is the line voltage and I is the line current and cos phi is the power factor. In star connected load, line voltage is root 3 time of phase voltage and line current is equal with phase current, but in delta connected load line current is root 3 times of phase current and line voltage is equal with the phase voltage. Now in an important factor, that is power factor, depends upon the type of the load. It is very essential, students. So according to the type of loads, this power will be I mean the load, if the load is resistive, inductive or capacitive, the power factor depends on the type of the load. Now we will have the circuit diagram over here. The circuit diagram is, there are two elements. For the element 1 there are two current coil and pressure coil. Similarly, for element 2 also there is a current coil and a pressure coil. So the connection is very simple. The current coil or the main coils are connected to the windings of the load, and the pressure coil are joined, or you can say they are connected to the other terminal of the load. Now moving ahead, let us understand the procedure. In the procedure part, we have we have to we have to make this procedure in the past tense. So we have connected the wattmeter and induction motor as per the circuit diagram. Check the connection point of wattmeter as indicated in the instrument. Record the wattmeter reading as P1 and P2 when switched on the supply, and note the wattmeter readings. Then the supply was turned off and the two wattmeters were replaced by a single three-phase wattmeter. So student, during initially either you can use the single phase two wattmeters and connect as per the given diagram, or you can also directly connect the three phase wattmeter and take the reading. So both of the cases you have to record the reading. So the connection was made as per the circuit diagram. After thorough inspection of connection, the circuit was energized and the reading was recorded, and multiplied by multiplying factor, that is 4. So students, this factor 4, from where it has come? Because due to the manufacturing side, it has been given in the circuit diagram that if you connect to the those voltages V1 and V2, which are prescribed in your wattmeter, three phase wattmeters, accordingly you have to multiply with some multiplying factors. So where in this experiment I have connected, the multiplying factor is 4, so the reading has to be multiplied with 4 here also. So for using single phase wattmeters, there is no such multiplying factor. So we have taken the reading for P1 and P2. What are P1 and P2? P1 is the single phase wattmeter reading. P2 is the single phase wattmeter reading for the other phase. And there is no three phase wattmeters connected in the first case. So we observed that the powers are 208 for P1 and 108 for P2, and it totally comes out to be 316 watts. So in the second case, we have installed only one three phase wattmeter, and it yields us a reading of 80 watts. So we multiply it by 4 so that its multiplying factor has to be multiplied. So it comes out around to be 320. I have written here 319 because of some errors. It was not exactly 80, it was lagging some fractions behind 80. So I have taken it as 319. So this is a minute error, you can say, from 316 to 319. So it can be considered that these two powers are same. So with this we concluded this experiment, and you can draw a conclusion differently also. I have concluded from the above observation, we concluded that by using 2 wattmeter we can also measure power consumed by a three phase load. That is the only conclusion, but apart from that I have written something which you require for your future for details about these wattmeters. So we also conclude that power depends upon the type of load, that is given detail below. So what are these details? If it is resistive, then cos phi becomes 1. If inductive and capacitive, L only and C only, cos phi becomes 0. If R and L, circuit, cos phi is between 0 to 1 lagging. If R and C, cos phi is between 0 and 1 leading. If RLC, circuit, cos phi is between 0 to 1 lagging or leading, depending upon the dominancy of L or C. Now, due to the zero power factors in only L and C load, no power consumed by the circuit, because power is equal to root 3 VL IL cos phi. Maximum power consumed by the circuit when the load becomes resistive, which is equal to root 3 V into I cos phi into T, where V is the line voltage, I is the line current, cos phi is the power factor, and capital T is the time. So by performing this experiment, we come to know that by using two number of single phase wattmeters, we can also measure the power drawn by a three phase circuit. So this was all for your ninth experiment. Thank you students for watching.